Probably not. Okay, so let's review what we talked about because we kind of need that for today. On Friday, you guys remember the rotation on the coordinate plane?
Yeah.
No.
We start here on the right, and then this is how many degrees?
90, 180, 270, 360.
And it keeps going. Okay, yeah, that's right. And then how did we find the reference angle? So let's say I had like a 250 degree angle. Where would that be? Well, if this is 270, 250 would be 20 degrees off. But what's its reference angle?
70.
Or I put 270. We figured out the reference angle is how far it is from the x-axis. So in this case, it'd be how far is it from 180? 250 minus 180 is 70 degrees. If it was in the fourth quadrant, you had to figure out how far it was from 360. Or if it's the second quadrant, how far is it from 180? Okay. That's all still in your brains, right? Remember it perfectly. Okay, we are introducing a new concept today, and usually people freak out, I think it's safe to say. So let me put these back. This is 0, 90, 180, 270. Okay, there is another way to measure angles besides degrees, and it is called radians. Okay, radians sounds like what? Radius. I think they made it up because if you're counting angles with radians, then the arc length is just the radius times the radians. So you guys remember theta is used for like the angle symbol a lot of times. R is radius. So this little formula, if you're using radians, this little formula tells you the arc length. So it's just handy. It might help a little bit simplify the sector area, but not that much. Anyway, how many radians are in a full revolution? So we got 360, right, in a 360 degrees in a full revolution. For radians, it's 2 pi. It starts here, you could say it's 0 radians here, but in a full revolution, they call it 2 pi radians, where pi is, 3.14. So you could also say it's about 6.28 also. Usually, more often, it will be written with the pi symbol rather than the decimal. Okay, so if a full revolution is 2 pi, then how much is 180 degrees? 1 pi. Yeah, so that's probably the best way to think of it. Pi radians, which is about 3.14, is equal to 180 degrees. That's the base ratio. So if this is pi, what's 90 going to be?
Half pi.
Yeah, and the way they usually write it is pi over 2.
So if we have pi and 1
And if it's in decimal, half of 3.14 is like 1.57. So, but this is the more common one.
So if there's pi, we could just, so if there's an equation with pi in it, we could just replace it with 180 to get the angle.
Yes. Also, your calculator, the nice calculators, maybe all the calculators in here, there's a way to switch, like if you want to figure out what cosine of pi over 2 or whatever, there's a way to change it on your calculator from degrees to radians. Probably if you look at the top of your calculator, you'll see a little D or DEG, and that stands for degrees. And it depends on what calculator you have, but setup, or you have to go to setup or something and find the radians option. Or you could do what Will said, convert it into degrees and then plug it in like the, yeah, it should be set in D. You want it set with the R or RAD, yeah, for radians.
So that means that if I just do
Okay, so if this is pi, and that's like pi over 2 up there, what would 270 be?
3
That's right, good job. It'd be a pi and a half, like 1.5 pi, or as a improper, it'd be 3/2. So it's 3 pi over 2. Okay, those are the most common. Have you guys flip to 453 yet? You see that it's called a unit circle that they drew. Not only do they have the things that I wrote, they have a lot of other common measurements in their conversion. So do you guys see where it says 30 degrees, pi over 6? Okay, that picture could be pretty helpful for you today and in the future when we do it. Or 45 comes out as pi over 4, or 60 degrees is pi over 3, and so on. Those are some common conversions between degrees and radians. But what if we just want to know how to convert everything, not just those special angles? How can we do it? So let's say I have some random weird angle like, I don't know, 176. How do I convert that into radians? Okay, the converter is, so you guys know how pi radians is equal to 180 degrees?
Yeah.
When you're multiplying by pi over 180, you're multiplying by 1, and it's keeping the value the same. So what you want to do is divide out the degrees and multiply in the radians. So the multiplier is pi, so basically this is what you plug in. This is not going to come out very nicely. Do they want...
44 pi over 44, or 45.
Okay. Yeah, if you have a nice calculator, it will write it like that for you. Like instead of the decimal. We don't really want the decimal today, I don't believe. I'm trying to check.
3.07.
We do not want that though, Will. So Will, if you want to do it with a fraction, just plug in 176 over 180, like with the fraction button, and then put the pi on it. Did you get it? She got 44 45ths.
176 divided by 180.
No, fraction button, 176 over 180.
What's the fraction button? Oh, the...
Yeah.
24 over 45.
Yeah, but then there's a pi.
Actually worked.
Yeah. Okay, but what if we want to go the other way from radians to degrees? So let me think of a random radians thing. So this would be a radians measurement. You can tell because there's a pi on it usually, although not always. Basically use the same multiplier. You want to multiply in the degrees, but you divide out the radians. Another way to do it, and this is how I do it, you just replace pi with 180, and that will do it. So it's kind of like 4 times 180 over 7. Does that make sense? So you can use this multiplier. This gets rid of the radians and turns it into degrees. Or my other way of doing it is just replace pi with 180, because pi is 180 degrees. So whatever that comes out. What does it come out to?
720 over.
Oh, okay. So it's, okay, whatever. The ones they give us will probably work out nicely. Let's jump in and see how this goes. Okay, pi over 3. So this is what I was just talking about. Pi is basically 180 degrees, right? So on number 1, it's just 180 over 3, which equals, let me write it like this.
How do you enter a degree into your calculator?
You don't. If you are using like cosine or something, your calculator will assume you're talking about degrees when you plug something in. Okay, unless you set it your calculator to radians, and then it'll think you don't plug in degrees.
So if I set
exactly.
it as degree, then it will automatically assume something's a degree.
like if you're doing trig functions, it'll assume.
And the trig functions are cosine.
Yeah, so when you plug in like cosine of 50 in your calculator assumes this degrees, because otherwise it doesn't make sense. Unless you change it to radians. That's the only time though that you'll need to worry about that.
So if I plug in that pi over 3 thing, it should, because I did the pi over 3, and it came out as that on mine. How do I change it to where it comes out as that?
You can't.
Yeah.
You just turn the pi into 180, so it's 180 divided by 3.
So pi is 180.
Yes, pi radians equals 180 degrees. So on number 3, it's pi over 5. So that's just the same thing as 180 divided by 5. Okay, 36 degrees.
So if it's next to something, how it is on 2, are you just going to do 3 times 180 over 2?
3 times 180 over 2 would work, yes.
Okay,
Okay, number 5, we're going the other direction. We are going from degrees to radians. So here's what you do. You divide out the degrees and you multiply in the radians. This is the multiplier you use every time. We don't want pi to turn into a decimal. Most of your calculators probably won't turn pi into a decimal, which is good. If your calculator does turn pi into a decimal, just plug in, like I told Will, 15 over 180, and then just put pi on your answer. What's it turned into, 1 over 12? Okay, so it's 1 pi over 12 or just pi over 12. It's like 1/12 of pi radians is what it means. It's like 1/12 of 180. Did everybody get that answer? Are we good on the calculators? Yeah.
My calculator doesn't do fractions. It also doesn't.
It does. It's kind of a pain in the rear though. You hit the, you do 15 over 180 and then you hit the math menu and then you, option 1 is fraction.
Oh, okay.
And then it'll do it for you. Yeah, even though that calculator does more stuff, it's not as convenient. Okay, so the next one is 175, so we're going to multiply that by pi over 180. I think, let's see, what does that reduce to? 35 over 36, I think? Am I right? Yeah, I'm right, okay. Okay, number 9. This time we have to draw it. So remember when we drew on Friday the rotation? You can kind of cheat. It's not really cheating, but you can look at that unit circle up in the upper right corner to help you out though. Pi over 3. You guys remember that pi was like 180, right?
Yeah.
So pi over 3 is going to be 1/3 of that, which is like 60 degrees. So that's why it's right there. So this is pi over 3. I'll put it right there, I guess. Pi over 3. Did it ask for the reference angle again? It asks for the reference angle in radians and degrees. It's even more than last Friday. So the reference angle, how far is this away from the x-axis? It's pi over 3 and it's 60 degrees. So really they wanted both of these for the reference angle. Kind of 3 answers. I'll probably make this a 1.5 points. Half a point for the picture, half a point for this, half a point for that.
I'm still lost on what you did with 5 and 7.
I multiplied by pi over 180.
So is that not just 180 over 180?
Huh?
Because pi equals 180.
Oh yeah, they are equal to each other, but this is how you convert it to.
Yeah, so wouldn't you just do 175 times 180 or not?
No, it's more like divide by 180. But just do 175, well, just what I wrote, 175 times pi over 180.
And then it'll just do that?
Yep. Okay, number 11. Where is negative 3 pi over 2? You might recall, maybe not, that 3 pi over 2 was the same as 270, like 3/4 of a turn. So if we're going in the negative direction, it actually looks like that. Negative 3 pi over 2. Okay. Then we're supposed to say the reference angle. So how far is, basically, how far is this in degrees? Let's start with that. How far is this in degrees from the x-axis? 90 degrees. So the reference angle is 90 degrees, or what's 90 in radians? Pi over 2. If you're not sure, the quick reference is in the upper right corner where it says 90 degrees pi over 2. Thirteen says 5 pi over 4. Where is 5 pi over 4? Probably in the picture as well, right? Well, 4 pi over 4 would be 1 pi, so it's past 1 pi. And it's a quarter of a turn past 1 pi, so it's like right there. And you should be able to find that in the picture in the upper right corner, the one that says 5 pi over 4. How far is this away from the x-axis? Okay, one way you could do it, remember how on Friday we subtracted, like we did this angle minus 180 to find out how far that was? You could do this angle minus pi to find out how far away it is. Pi is the same thing, if you want to do it by hand. 1 pi is the same thing as 1 over 1 pi or 4 over 4 pi. So anyway, it's like a quarter of a pi, a quarter of 180 away. Okay, you guys see how I did that? Instead of subtracting 180 to find out how far it is away, you subtract pi. And you should get pi over 4. And how many degrees is pi over 4? I don't think I drew that in my picture earlier.
It's 45.
It is 45 degrees. Again, if you look in your picture and you find pi over 4, that red angle in the upper right quadrant, it says 45 degrees pi over 4. So these two are the reference angles.
Can you go back up to 11 really quick?
If you can get all three of them in there, so you're just gonna take whatever you get from that number, minus it by pi, and it's gonna be good.
Well, if we were in the fourth quadrant, remember how we did 360 minus that to find the, it would be 2 pi minus whatever.
But since we're,
If we were in the fourth quadrant, like if the angle was over here, the reference angle would be how far is it from 2 pi instead of how far is it from pi. This is pi, this is 2 pi. So if we were in the fourth quadrant, we'd do 2 pi minus this angle.
and how do you find that angle again?
Well, okay, this angle down here was 3 pi over 2. So it's like 1.5 pi. If anything is bigger than 1.5 pi, it's going to move up here.
So you're kind
Between
of
1.5
ballparking
and 2
after
pi. Be in there. What?
that. You kind of ballparking it after that.
Yeah,
So that
it's
there
kind of
would
rough.
be like, it'd be like,
They're probably not going to give you an angle. I don't
3.5.
think. That's not one of these examples.
like up there, it would just be like 3.8 pi or something like that, for where you just had that one line.
Well, this would probably be like, what's between 1.5 and 2 would be like 1 3/4 pi, which is like 7/4 pi.
You're not trying to find where you put that circle at?
The circle just gives you a visual of the rotation.
Okay.
It's not the actual angle. The angle is from here to here. Circle's not really. I mean, it kind of helps. So the visual is needed. Number 15. Okay, they are giving you the formula in the directions. S stands for. I mentioned this at the beginning. S stands for arc length. It's really easy though. The arc length is equal to the radius times the radians, the angle, radians. Okay, so you're just gonna be multiplying those two things together. So on number 15, it says the radius is 5, so that goes for r, and the theta is 2 pi over 3. Okay, so they have some kind of circle, the radius is 5, and the angle, where's 2 pi over 3? 2 pi over 3 would look more like that. The radius is 5, the angle is 2 pi over 3. So the good thing about radians is if you just multiply that together, it tells you what the arc length is. How long is it from there to there? So if we plug that in, 5 over 1 makes 10 pi over 3.
It says to the nearest.
Are you shaking the table?
Sorry.
Oh, it does say we're supposed to round to the nearest
10.5.
tenth, doesn't it?
10.5, yeah.
Okay, in this case, it kind of surprised me. I thought they were going to leave it like this, but they actually turned pi into a decimal. So if your calculator gives you this answer, you need to hit the like SD button or whatever it is on your calculator that turns it into a decimal. And yeah, this comes out to 10.5. Does everybody know where that button is on the calculator? If not, you're going to have to ask probably later. How do you turn it into a decimal number? 17. Okay, what's different about 17? There is something different.
There's 2 pies. There's no.
They're giving us the S,
So do we just?
the arc length. So in other words, 3 pi is over here on the left with the S. And they're not giving us the R,
So is it just?
but they are giving us the angle, 6 pi over 7. Okay, so how do I solve this for R then?
Do you divide by?
Right. Since this is a multiplied value, to get rid of it, to get R by itself, I would have to divide by 6 pi over 7. So it's 3 pi divided by 6 pi over 7. And we do want a decimal, so will your calculator actually be more convenient in this case?
Well, I'm trying to figure out when you got the answer on 15.
3.5.
It's right here, Will.
Yeah,
5 times.
Yeah, I know. I'm plugging that in and I'm getting 600 every time.
Okay, the 5 is not, well, how did you get 600? I don't know. 5 times, you could, Will, you could plug in 5 times 2, I don't know if your calculator wants you to do times pi. You might try plugging that in, see if that works well. I replaced the fraction bar with the division sign.
So we just did this 3.5.
I got the answer right.
Okay. 3.5, yeah.
Divided and multiply.
Okay, because the variable is right here on this one, instead of over here by itself. This one said S equals. They gave us different values. They gave us the S
Is that
value.
because the O starts first, or starts with the O first before the S?
No. So they gave us the S value, which is this one over here by itself, and the theta value. So to solve for R, we have to get rid of this theta value, the multiplied. And it's multiplied to R, so you have to divide it. It's kind of like if you have 10, like 10 equals to X. How do you solve that for X?
5 times.
You divide by 2. So since this is multiplied to R, we had to divide it. Just like you divide by 2 on this one.
But why?
On this one, they just gave us,
Would you do the same thing
The
for
di-
20?
20 gives you theta and S, yeah, so it's the same as 17.
Okay, then that gives me, that's fine. Thank you. Or wait,
How far are we going? 20? One more?
So we're going 20.
19.
then what do you do on 18 when it's R and S?
Well, it's kind of like 17, it's just a different variable.
So I have like an algebra problem.
Okay, you just plug in, this is the formula we're using, it's in the directions, S equals radius times theta. You just plug in the numbers that they give you in the spots that they go. So on 1936 is the R, theta is 15.
Oh, this makes all my sense. Okay.
Okay, here's a problem though. Actually, they threw a curveball on us. They did this on 19 and 20. What's different about 19 and 20? Okay, it's in degrees. This formula does not work with degrees. It's for radians only. So what do I have to do? I gotta convert it. So you guys remember the converter from earlier? We want to multiply by pi over 180 to convert that. What's that come out to? One is pi over 12, wasn't it?
Yeah.
Yeah.
So now if I plug in pi over 12, that should actually work. And the decimal answer would be 9.4.
Like 70.
I don't remember where, but is this 17?
Yeah.
Is there a special unit size for 19?
Well, it just says it in the problem. It's 19 there, talking about meters. I'm not really gonna grade it on the labeling though, but